Good morning. I'm really happy to see all of you here. And we're going to talk today about GraalVM, a high-performance polyglot virtual machine. And this will be a very practical session. So we're going to just cover very basic information about architecture and components and things just to get you all started to understand what it is and what it can offer. And then we'll dive straight into actual demos, which I hope they all will work. My name is Oleg Shalaev, and I come from Estonia, from a small town of Tartu, and I'm a developer advocate for the GraalVM team working for Oracle Labs. Oracle Labs is the research and development facility, department within Oracle, and its goal, its mission, is to research and produce academic research about what's possible in computer science and software engineering, and then convert those findings into hopefully successful products for the whole community, and, well, incidentally, for Oracle. So GraalVM is one of those products that was in the research for at least 7 years now, and lately it's making its move from purely academic thing towards being an industrial project. If you have any questions, but you are not ready to ask them, or you come up with questions later, you can find me on Twitter, and you can ping me, and I will be happy to answer all your questions. Before we start doing any technical discussions, please do not make any forward-going business decisions on the contents of this presentation. Thank you. So, GraalVM. GraalVM, as I said, is a high-performance polyglot embeddable virtual machine. It seems a little bit that there's just a bunch of keywords slapped together to make something as interesting as possible. It just lacks machine learning and blockchain. But this is true. And on a series of examples today, we're going to go through and see how GraalVM can run your code in different languages very efficiently, how it can allow you to interrupt between different programming languages, and so on. So everything that we're going to cover here, most of that is based on the blog post by Chris Seaton. He's a lead of Ruby project for GraalVM. So GraalVM currently can run a number of languages, JVM-based languages, Java included, Scala included, Kotlin included, and so on. But it also can run other languages like JavaScript or Ruby. So Chris is the lead of the Ruby team, and well, he's also an excellent writer, so he wrote that blog post, and we're going to go through most of that. If you want to follow, if you want to try it at home, you can find that. You can find all the examples there, and move on. So, without further ado, let's see what GraalVM can offer you, and let's be very practical about it. So, what you can do, you can download that, you can obtain that GraalVM. It's a package, right? It's a distribution of the virtual machine, kind of like Java. You can download that, you obtain that on your machine, and then you can experiment with it. So I downloaded mine into this directory here. You can see that it is release candidate 2 and of 1.0, which signals the world that GraalVM is ready to be released very soon into the actual production use with 1.0. And what we would like as a team currently for the community to try it out, to figure out how you would like to use it. And if you find any features that are lacking, or if you find any issues, to report to us. That's why we left ourselves a little bit room to figure out things before 1.0. So you download that, you unzip this package. What do you get? You get a very sensible thing that kind of looks similar to your JDK. You can see that you have your Java executable and your JavaScript executable and your Node executable, your interpreter for LLVM languages, and a bunch of things. So what it can do, GraalVM is based on the JVM, on the normal OpenJDK build, currently supporting version 1.8. You can also build certain components of GraalVM for other things, but it's just normal Java. So if you do Java version, you can see that GraalVM can run simple Java programs. It can also run more comprehensive Java programs. So I have this random demo of Kotlin Reactive Web Application, and I can run that with my GraalVM. So let me just Gradle it. I will build it, and I will run it. And there are often confusion, but GraalVM is a fully featured JVM implementation based on the OpenJDK builds. So everything that your normal Java can run, GraalVM will be able to run as well. One of the most interesting components within GraalVM running in the JVM mode is the compiler. So the main difference from the normal JDK is for running Java programs is that GraalVM features a new compiler called Graal. And that compiler is really great for optimizing your code. So you can see my application started here. Let's see what it offers me. So if I just open this application, whoa, it serves me a picture of the architecture, what GraalVM can do. I just didn't want to do that as a slide. So GraalVM, what it can offer you currently? It can offer you running multiple languages, Java, JVM languages, Scala, Kotlin, JavaScript. How many of you write JavaScript, more or less, every week? Not many. So I assume you're all back-end engineers, just doing distributed systems and hardcore things. Excellent. It can also run Ruby, R. We have a Python implementation coming up and shaping nicely. Very interesting that. It can also run native languages. So all your C, C++ or libraries that you always wanted to use through Java, but kind of didn't want to mess with JNI, you can run that differently. And in the middle, there is GraalVM, and what it does, it transforms the interpreters from those languages into very efficient compilers for the machine code. So you take those languages, and it can run them very fast. The program's written them very fast, because it compiles them to machine code very efficiently. On top of that, it can run in multiple environments. So it can run in the JVM mode on the OpenJDK. It can run as a Node application if you're writing Node applications, and you can leverage all those languages. It can run and is embedded into Oracle database, so you can run your JavaScript code inside the database. For example, if you don't want to write sort procedures as PL/SQL, you can do that. The MySQL integration is coming up. I don't think it's public yet, but it will be public in the upcoming weeks or months, depending on certain conditions. And it can also compile your Java programs, some of them, not all the Java programs, but it compiles them into native executables. You can run GraalVM, and you can obtain from your Java program, you can obtain an executable blob that you can put into your container and run as a standalone native image, making Java very much more interesting for example, cloud deployments or microservices, where you would like to reduce the size and memory overhead and everything. So it's very versatile. How does GraalVM achieve that? Well, it's a layered cake. As everything in computer science and software engineering, there are layers of things. The more layers you get, the more functionality you get. So if you look at the architecture of GraalVM, and there is a different picture served by the same Kotlin web application running on GraalVM, there are a number of layers. So at the bottom, as a platform, GraalVM employs normal Java hotspot virtual machine. The GraalVM team provides certain binaries that you can download and you can run easily on your machine. There's also the best part of this project, because I see a couple of concerned people here. It's fully open sourced. All the components for GraalVM are open source. The source code available on GitHub. The license for the core components is GPL2 plus ClassPass exception, the same as OpenJDK. The license for the language implementations is even more permissive. Typically, will be universal permissive license, or some of them are under Eclipse public license, something like that. So those components you can touch, you can download, you can stir the code if you want, you can build them, and you can improve them. And we certainly hope that the community will at least consider contributing. So at the bottom of GraalVM, it's Hotspot VM. The most important part of this whole GraalVM project, as I said, is the compiler. So the compiler integrates with the JVM using the JVM CI. JVM CI stands for Java Virtual Machine Compiler Interface, right? It was a feature added in Java 9 to allow developers specify a third-party compiler implementation to integrate with the JVM. So For our JDK 8-based builds, we backported JVM CI, and through this JVM CI, through the official channel how to integrate with the JVM as a compiler, Graal compiler sits there, and JVM passes it the bytecode to optimize, and Graal compiler looks at that bytecode and produces machine code. How successfully it produces the machine code, we'll see in a minute. So through that machinery, through being able to just take the bytecode and output the machine code, GraalVM can run JVM languages, right? Everything that compiles to JVM, a bytecode, can be run. Java, Scala, Kotlin, etc. Now, for other languages, it's a little bit more harder to implement. So typically, an approach would be to take the language and to produce a compiler from the language to the Java bytecode. This is the way how previously we've implemented JVM-based languages. But it is a hard thing to do. You need to know the semantics of the language. You need to figure out how to compile specific statements to the bytecode. If your language features constructs which are not really directly translatable to the bytecode, if your language is not similar to Java, it's kind of hard to do and hard to maintain, especially if your language runs forward. So what GraalVM offers, it offers you a framework for implementing managed languages called Truffle. Makes me hungry a little bit every time I hear Truffle. It's a framework that offers you a jar file with a certain API, with a certain number of annotations, and what you as a language implementer have to do is you need to create an interpreter for your language, right? You need to figure out how to parse your program into the abstract syntax tree, so just the normal tree of operations, where you would go through that tree and evaluate the children nodes first and then the parent node, kind of like the first step when you implement a language, you would do that. And with GraalVM, this is all you have to do. The GraalVM with Truffle will take that tree, will take your interpreter, look at that, gather the information, and run it and compile that into very efficient machine code. So through that machinery, we've implemented JavaScript, R, Ruby, and Python. JavaScript compatibility is currently at 99% with ECMAScript 2017, which is a fairly recent standard. I think they have the 2018 coming up, and we will support that really soon. So what else? On top of that Truffle framework for the interpreters, we've implemented the interpreter for LLVM bitcode. LLVM is the compiler toolchain, right? It is a project that was created to take your native programs in C, C++, and so on, transform them into this intermediate representation, the bitcode, kind of similar to Java bytecode, to then have the compiler that can optimize that and compile to native code, right? So this is the C project or C++ native programming languages project. So what we've done, we've implemented the interpreter for the bitcode. So with that interpreter, we can run LLVM bitcode on top of the JVM. Surprisingly, it's really fast. Our measurement, I think last year summer, were the following. We could run Java programs based on the benchmarks a couple of % faster than Hotspot. We could run Scala programs approximately 20–25% faster. And I think it's improved recently even more. Ruby R, the performance boost off the charts because the default implementations are not really optimized for performance. In general, if you want a platform to be very performant, to run fast, you need to invest very many effort and money and hours into making it fast. So JavaScript implementation, currently we are approximately at like 85–90% of speed of V8. And for example, I think that is 5 to maybe 6–8 times faster than Nashorn, depending on the benchmark, but we are challenging the actual default implementations for the virtual machines for those languages. This is not yet 1.0, so it will improve. The team is committed to make GraalVM the fastest virtual machine for all the languages it supports, and I think we will get there. The speed of native interpreter is approximately at 85–90% of native code as well, which is mind-blowing. So let's stop looking at this pretty picture and let's go and see how that code operates in action. So what I have for you here, I have a benchmark, right? When you want to see how fast a certain virtual machine is, what you do, you create benchmarks. And this is, by any means, not the most scientific benchmark that you can come up with, right? It uses JMH, so it kind of doesn't fall into certain traps for implementing micro benchmarks. But what it does essentially, it takes an array of integers and it streams it, and it applies some operations on top of that. So how many of you run Java 8? How many of you run Java 9 and above in production? Several hands dropped. So this is a fairly typical code that you would write as a developer working with Java 8, right? You will have your objects, you will stream them, you will use the stream API implementations, you will map things around, and this is something that you can find in the user code. What I will do now, I will stop this application not to hog my resources, and I will go into this different window. So if we look at the run no Graal thing, because I would first want to run it without Graal, what you can see that I will use my normal Java and I will disable the JVM CI compiler. So if you want to run your normal Java, but you want to run it on JVM without any Graal compilation happening, you can disable the compiler. The same way on more modern Javas, for example, JDK 10, you can type unlock experimental options, -XX plus, use the JVM CI compiler, and you will be running a version of Graal imported into OpenJDK sources, like a snapshot of Graal compiler with your stock JDK. It's available in JDK 10. It's not the bleeding edge of the Graal compiler that we are currently gonna be running, but it is a version of that. So if you'd like to experiment for your Java code, it's literally, and you're running Java 10, not in production, but somewhere. Don't experiment on your production. This is not the wise thing to do. But on your development machine, it's one option away. So let me just run this while we are talking. So it's a benchmark. It will run. Currently, it will run just with the normal hotspot C1, C2 compilers, right? The benchmark harness, the micro benchmark harness will warm up our code, so it will have to take a couple of seconds to run iterations of those methods, and it will give numbers to us. So currently, we are measuring the time that it takes for operation to finish. So you can see that it runs for, I think this benchmark runs for approximately 40 seconds, and it runs a couple of iterations. It uses JMH 1.21, which is the version where JMH developers added support for GraalVM and kind of tested that it doesn't break the JMH assumptions, at least in the very obvious ways. So we use that support. We run this benchmark. You can see that to run one instance of this operation, it takes CT approximately 185 nanoseconds per operation. Run. So now I will run this with just GraalVM. So I will not use the disabling JVM CI compiler. So if I run this with GraalVM, it will do the same thing, but just with GraalVM. I will not show you the numbers. Let's look at the benchmark. Who thinks they could have written code like that somewhere in their application? Okay, yeah, decent code. Maybe not exactly manipulating integers, but similar. So now, who thinks this benchmark will run faster in GraalVM? Okay, not many people. I agree with that opinion. JVM is a state-of-the-art virtual machine. It's really fast. A lot of effort were put into optimizing the compiler. So who thinks it will be slower? Why would I show you benchmarks which are slower on GraalVM? So it will be faster. The question is now how much? Who thinks it will be faster, like 5%? Okay. Who thinks it will be faster 20%? 2 times faster? I mean, you're optimists. It's a JVM, right? It's really not that easy to be that much faster. 1-2% is considered a significant improvement in the JVM performance, right? So let's look at the numbers. So with this on this benchmark, running with GraalVM, we can see that one iteration of that operation takes approximately 10 nanoseconds per operation. 185 without Graal, 10. This is what? 18 times faster? But this is not a scientific benchmark, right? It's running on my Mac, which is overloaded with other random things running. It's also a Mac. It's not like, unless you run your production environments on a Mac, don't take this number super seriously. At the same time, you have seen that 18 times performance boost is possible on the code that you could have written for your day-to-day projects. So if this doesn't pique your interest, I should work harder. But it should pique your interest. Like, we can run Java code significantly faster, snippets of those, right? On some code, the improvement will not be that much. But on some code, it could be significant. If you get like 30% improvement and you're running your production in a cloud environment, that is 30% off your cloud bill, right? It is 30% of throughput that you can not care about when you implement additional features to add value to your users, right? This is free stuff for your performance things. Let me show you another example of this magnificent performer things. Why it is so great. So we'll look at this snippet of code. I will not run this against the normal JDK, but I would want to show you what GraalVM can do for you, and talk about how it can implement those things a little bit. So let me just run this, and so if I run this Blender, yeah, I run this with GraalVM, everything is good, right? It just, what the code does here is, it just initializes a color plane or cube, and it manipulates and crunches numbers. And you can see the results. How do I make it larger? Yeah, you can see the results. And it runs at approximately 500 milliseconds for an iteration of the loops, which goes through the color plane and does some color manipulation, right? So one of the things that Graal compiler excels at is high-level optimizations, right? So it not necessarily looks at the low-level bytecode patterns and says, oh, I see string buffer, append, and I will optimize that into machine code. Here's the thing. But it also has a number of high-level optimizations. One of them is the practical escape analysis. What Graal is excellent at is at looking at the code and saying, you know what? This object cannot escape to the main memory. This is my local object. And thus, it doesn't have to initialize the full objects, and it doesn't have to produce garbage on the memory. So it lowers the memory pressure. What I will do now, I will introduce a condition here. If x equals y and y equals z, or z, as some people would put it, I will save it, right? So now what we did, we just do the same work with the color. So we do the same thing, but we only assign that color back to our memory, right? Back to our plane of colors in a certain situation where we are on the main diagonal, right? So for the most part, we don't do anything with that color, but for some objects, we do need to put it to memory. So this will not lead to significant improvement of performance on the normal CTU compiler, because it still needs to do all the operations. So we only skip one assignment, right? If we run this with Graal, remember, 500 milliseconds. And the result is that with this small change of code, which albeit this is a functionally different program, right? But it optimizes it into almost nothing. So what happens is that Graal compiler looks at this code and produces code like this. It puts the heavy computation under the conditional, and it can do that much better than the normal hotspot compiler. So this is one of the optimizations which gives such a performance boost to the programs running on the JVM. If you're running programs written in other JVM languages, not Java, you will probably enjoy a much better boost on average. The reason for that is because CTU and Java programs, they intimately know each other, right? They were created through 20 years of history, side by side. And they know how to optimize each other. Java code, heavily optimized, knows about C2. C2 knows about the pattern of Java code. Other JVM languages, not so much. They produce different patterns of bytecode, and sometimes they're harder to optimize using the conventional Java compiler. So if you're running Java code, this should be enough to make you at least try it. Download, look at that, subscribe to our mailing list, maybe, at least. The least amount of effort that you can put into. Now, this is not everything it can do. Let's see that. You can take what you can do. You can take certain programs and you can compile them into the native executables. Let me show you this fascinating Java class. List directory. What it does, it's a normal class, it's a Java class. What it does, it manipulates some file system. So it takes an argument and it walks the file tree and it collects some information about files and it prints that information back to you. Right? So what GraalVM can do for you, it can create a native image of your program. So there is a native image utility inside the GraalVM distribution, and you just feed your Java program to it. You package a self-contained fat jar of your application, or you provide the class path. What it does, let me run it. What it does the whole analysis of which classes are accessible from your program. It looks which classes are initialized, who refers to who, and then it compiles that into an executable thing. It takes a little bit of time, especially on the poor MacBook. It can compile things on Linux. It can compile into a statically linked executable. So you just have one blob that includes everything. So you can use it in an empty Docker container, for example. But the best part of this, so the startup of the application compiled to a native image will be much faster. The memory overhead of the runtime will be much lower, right? So now we have this native, this list-dir native executable. So it walks the current file path and it prints the information. If I time this, how do I time this? Oh no. No, time. No, oh. If I time this, you can see that it starts in absolutely no time. I can also run it using the normal Java, and it will take some time to initialize the JVM. And it might be not such a large time for this small program, but it can be a significant piece of time. With the native image, it is much faster. So currently, how it works, there is a thing called Substrate VM, a special VM implemented in Java. So you can look at its source code, and if you read Java, you will understand it. So the VM is implemented, it produces, it has its own implementation of the garbage collection, which is a generational scavenger. It has its own implementation of the code caches and thread scheduling and everything that JVM has to provide as a virtual machine to this thing. And it can leverage the Graal compiler to compile into native executable. What it also can do, since it compiles into native executable, it can be used to be embedded in your native applications. Or if you just talk about Java, to be embedded in your Java applications. So you can enhance your Java applications with a very fast JavaScript or Python or R. Or you can embed it in a native application. So the current implementation has some limitations. So not all Java programs can be compiled this way into native executables. So why I'm saying is this, because if you will be super excited about that and then you find out that your favorite Spring application currently doesn't build into native executable, you get kind of sad. But we are working on that. So currently, the things that compile, the biggest obstacle is dynamic class loading. Because when you're native executable, it's not so easy to find and dynamically load classes unless you re-implement the whole JVM, which is not the goal here. So dynamic class loading is currently not supporting at runtime. Everything else is supported to a certain extent. So reflection, you need some configuration. GNI, you need some configuration, but you can overcome that. We've compiled native applications to static images. We've compiled some, I know that some Spring Framework applications can be compiled to native images. Albeit note the default ones from Quickstart. Your Scala C compiler, who writes Scala? I have great news for you. First, GraalVM can run your Scala code approximately 30% faster. It can also run your Scala C faster, so you won't be waiting for your code to compile so much. And then you can also compile your Scala C into native image, which will be starting up faster. You can also compile your Java C into its native image. So there are examples of non-trivial Java programs that can be compiled to a native image like that. And then you can expect great speed up for your startup and low memory overhead. Think about the possibilities it offers for your cloud deployments. Let's not talk about that anymore. Native executables. Who are we? Let's talk about Polyglot. So I will run my application here. It's a Node application. I will show you the code in a minute. So you can see that I'm starting my Node executable, and I say that I want to run on the JVM and in the Polyglot setting and my server. What the server application offers you. Server, what? Server, JS, no, not like that. Polyglot, oh, right here. Server, application. What is this? This is a normal JavaScript application. It requires some Node modules, it creates a web application, it also uses some Java types. So if you would like to use your Java types in a dynamic program, and if you're writing Java for a living, probably you have libraries that you want to use, then you can do that. So, and then it binds on a certain port and it does text manipulation. It uses normal JavaScript, then it adds some Java computation to the thing using Java standard library classes. For example, here, a big integer. And then it does evaluation of R code. R is the code for machine learning, for data science, for data visualization. So if you need to visualize something and you don't want to figure out how to do that from Java, you can use R from your program. And it produces some SVG image, and it prints it back into your thing. So now if I open this, let me open this. I hope it's port 3000. Oh my God, this is so bad. I need to talk to you about this magnificent thing called, wait, which node? I will do this, and I will run this, a different command here. Minus JVM, minus polyglot, server JS. No, what? RCT, oh yeah. Sorry, pass. Excellent. So, when you download the GraalVM distribution, right, what's built inside? You have Java by default, you have JavaScript by default, you have LLVM interpreter by default, right? So you can run those things out of the box with just downloading one distribution. For other languages, which currently have a little bit less refined support and compatibility, right? So, for example, R compatibility is not 99%. So we didn't put that into the main distribution that you download. You have to install support for the languages. It is one command line command away. There is a utility called GU, Graal Updater. If you can see here, where is this? GU. And you can do GU install Ruby or R, and it will download the files from the internet and install them into your GraalVM distribution. So for some reason, I didn't do that for RC2 build, but I know that it's supposed to work on RC1 where I did this. So, sorry about this confusion. See, you can have native, regex, JavaScript, LLVM, Ruby. I installed Ruby, but not R. So, on the first time, when you download this, Graal will need to compile the runtime library for your language support, and it will take a little bit of time, like seconds, running on the JVM. But after that, you can see that it's going to run faster and faster and faster. The same way it can optimize your Java code, it can optimize the code in the other languages. So it will compile JavaScript, it will compile your R code, You can see that it redraws the plot of this fascinating SVG image here, and it runs as a single program. So now you can have the power of the whole ecosystem of that software developers created, not just Java. So we are not talking about just Maven Central, which has everything a person could need, something like 200,000 libraries, but also the whole power of NPM. Node Package Manager is at your service. They have 500,000 libraries there. It could be a good thing, it could be not the greatest thing ever, but they have code there that does useful things. So now with GraalVM, you can just use that code and glue it together to provide your business with additional value. Or R code, or Python for machine learning. The possibilities are endless. If you are a little bit concerned that this code is not something that you would like to write in production, because it's true, writing code inside strings is not the best idea ever. Have no fear. So what Graal offers you, it offers you a thing called Graal SDK, which comes with the API for polyglot programs. So it gives you API and classes to work across the language boundaries in a consistent framework across all the languages. So for example, this is my Spring application. Right? Normal Spring Boot application, what it does here, it does fascinating things. So it builds the context here as a bean. It builds a context, Graal context, which is a Graal class from the GraalVM polyglot package. It builds it, and it provides this context for evaluating languages as a bean. So far, so good. Then it uses that bean, auto-wire it into a different bean function, to get a plot function. What it does, it goes into the a certain resource, plot.r file, and it evaluates that resource, and it binds the result to the function. Don't just expose your functions as beans, because give them names and things, but this is a normal bean, and auto-wires that into this function. Let's look at the plot.r. This is a normal R code. Just defines a function, it does some SVG implementation, and Spring will auto-wire that R function into this function. And then inside your Java code, you can just use that as normal. You will just apply that, you will pass Java objects there, you can call from R and JavaScript and Ruby back into Java. If you're interested in this application, if it runs, let me run this. Don't run Blender, run Spring R application. Damn it. No, this will not work. There is no R currently for RCT. But it will work the same way. It will print SVG to your browser screen. So, and this code looks much more manageable than writing code inside strings. Who likes this code more than writing code inside strings? Excellent. Who didn't raise their hand are probably asleep, because this is way better. So, GraalVM brings the power of polyglot things to you. One more thing, very exciting thing. Not so much time, but you can see it loads packages. It also can load packages installed from normal things, so from NPM and from your R package repository. What else it can do? It sits. Imagine, GraalVM sits between your languages and your runtime, right? So it's in the middle of the things. It knows about the implementation of your language because you provide that with the interpreter for that. So what it is a perfect opportunity to do? It is a perfect opportunity to integrate tools that you want to use as a developer with GraalVM and automatically get support for all the supported languages. So let me see if I can do this correctly. This is a very complex operation. I need to pass the --inspect option here. Fantastic. So now we're going to run the same Node application with the debugger. So we're going to use the Chrome debugger. You can also use the profiler and other things. Heap viewer, memory consumption. And you can see that it integrates with Chrome debugger. And you can put breakpoints. Let me put a couple of breakpoints here. Let me also put breakpoint here. And then we'll trigger this. This should be fascinating. So we hit the breakpoint. You can see we are in the JavaScript code currently, right? We have our call stack. We have our local variables. What we can do next, we can step into the next function call. Here. Where are we? What happened? Wait. Something's wrong? No. Stop. Anyone knows what's happening? Yeah, okay, yeah, it loads. It was loading slowly. So now we are debugging our code with the JavaScript debugger, which is fascinating. And we step out of the current function. We step over, and we can debug. This will be more interesting, because here we have our R code. We have our R stack and variables. And we can step over here, and we can see. Come on, you can do this, machine. We can see the values and everything. You can debug your R program with the tool designed for your JavaScript program. And you can also use Profiler for the polyglot apps. There is other thing that I really hope will work, but I'm not sure if it will work or not. JVisualVM. Who loves JVisualVM? Who uses that once in a while? So GraalVM distribution comes with the bundled version of JVisualVM, which knows about Graal applications and things. So what it can do, it can find your applications, and it can work. I'll show you later. I have 7 minutes. I want a different thing to show. But JVisualVM bundled with GraalVM will work for polyglot applications. And you can see the heap values and query the heap using our console. And you can see which JavaScript objects take your memory and everything. And it will work for those polyglot applications the same way it works for your normal Java applications. It's fascinating. So you can, what GraalVM offers, it offers you the capability of introducing tools that are language agnostic. Right? You don't have to think about what language you are trying to support. You can support all of them at once. So, without further ado, let's go into the very interesting thing, embeddability, right? So the same way GraalVM can be embedded into this native executable, right? It was designed to be embedded in different kinds of Java programs and native programs. So one very important to Oracle native program is an Oracle database. Who uses a database in their day-to-day life? Not necessarily Oracle one, any database, right? So you write queries, you store data there. The current reality is that the amount of data that you get and you store grows much larger than your network and your computational capabilities, right? So what is necessary at some point is to move your computation towards your data. So you would like to run some computation inside the database, not to stress network back and forth, not to load the infinite amount of data. So typically how you would do that, you would write stored procedures using a language called PL/SQL. Who knows PL/SQL? Oh, wow. That is a better response that I typically get. Who doesn't know PL/SQL or doesn't feel comfortable writing PL/SQL? See, much more. Many more people. So if you are comfortable writing PL/SQL, good to you. Like, you should continue using that. It's a great language. It's heavily optimized over the last 40 years to be very efficient. If you know how to use that, use that. If you don't feel comfortable using that, but you would rather write, say, JavaScript, because there is much more code available in JavaScript readily for you than in PL/SQL, then you can do that with currently certain experimental builds of the Oracle database and MySQL database support incoming. It's actually done, and I've seen that in the works, but it's not public yet. But since I can talk about that, so it's on the way to be public. So what I did here, I downloaded the experimental build of the Oracle database with the multi-language engine embedded. So there is a Docker download. You can download a Docker container and run it. if you would like to try that. So I did that. So we are running here in a Docker container. So what I did here in this other tab, I created a SSH connection to that Docker container, right? And I'm running this bash, right? So we are in this Docker container. This will take a little bit of time, so I will just copy snippets, right? What I can do now, I can run SQL Plus into this database. But what I can also do, I can do crazy awesome things with running JavaScript inside database. So I will create a directory, normal directory, and I can do cd just normally, right? And I will do, I'm not sure why I'm copying this, but I'm nervous. This is an exciting moment. So we'll create an NPM application, right? We would like to get some JavaScript from the internet with certain functionality and put that into the database to work as a stored procedure for us. So what I will do npm install validator. This is the npm module. What it does for us, and you can see it installs. What it does for us, let me show you that it's actual module, right? An npm validator. It can validate strings for certain things. So for example, it can validate if a certain string is an email. So typically, if you would like to validate a string for email, being an email, you write a regexp and you debug that for years. If you have to write that in PL/SQL, I honestly don't know. I'm not a PL/SQL expert. I would not even attempt to do that. So now what I can do, I can just say npm install validator and get that functionality. Now to integrate JavaScript, which is not the most strongly typed language, and the database, which is extremely strongly typed, right? You have columns, they have values, they have types. I need to install types, which is a great thing because the TypeScript community, TypeScript is a superset, a language, a statically typed language on top of the JavaScript. So it introduces types to JavaScript. Great language. If you have a chance to look at that, look at that. But what I do, I install types for the validator package, right? So now I have this connection between JavaScript code, possibly JavaScript code and database types. Now what I have to do, I have to deploy this validator module into my database here. You can do that from the outside or from the inside. There is a utility that you can use. You install that and it runs currently within this Docker container, taking this JavaScript and adding that to the running database to offer me the functionality from that JavaScript as normal functions, right? So now, all this that you can see, all those functions are available to me within the database. So what I can do now, I can do this crazy thing called SQL Plus. We are in the database. We can do select one from dual. This is the syntax to select one from a dummy table, just nothing, doing nothing, returns one. What I can do now, I can use my validator the normal way I would use that. I will, this is hard, I need the proper apostrophe here. oleg@oracle.com, right? From dual, semicolon, very important. If you don't put semicolon, it will throw a different result at you. So now, what this code is going to do, it's going to call the GraalVM embedded engine to evaluate a piece of JavaScript within my database and pass database values to that. What has happened? Select validator is email. That was anticlimactic. oleg@oracle.com from dual. And you see the result is 1. If I do the same thing, but validator is email, just with not an email, to show you just Oleg here from dual, you will see a different result because Oleg is not a proper email. You see 0, which represents false in the database. So you can use the power of modern libraries on any platform that GraalVM supports. Java, JVM, standalone applications, you can compile that and use that, your JavaScript and Ruby and so on. You can use that in the database. You can use that to speed up your Java programs. You can do many things. The most important thing that you can do is download the version of GraalVM that you would like to test. There is an Enterprise Edition which comes with better performance. You can use that for evaluation, so you can freely try it in your environments. And you can participate in the community. So it's fully open source project, as I said. You can find the docs and getting started guides and everything on the website. You can share the code on GitHub. You can ask us for implementing things. We are committed to make it a great open source project. And yeah, join the conversation. Ask things. Tweet at us. Join our Gitter chat room with questions. Implement a programming language. If you wanted to implement a programming language, now is the time. It has never been as easy to implement a high-performance language as now. Build tools, or just try it out and see the performance boost it gives you. With that, I'm out of time. Thank you for your time and your attention.